Okay, I just started recording. So, what else we have? Okay, so yeah, let's talk about the partitioning techniques, right? So, you know what is hash partition and entire partition? Okay, let's see. If I have a data like this, and if I apply round robin partition, this is another technique. If I apply round robin, so how the data will distribute? Let's assume I'm having two nodes, node 1 and node 2. Round robin, it roundly distributes the records. First record to first node, second record to second node. Again, third record will start from first node, 20, 20, and then 30. Okay, this is how round robin partition will work. Okay, so hash partition, what it does, all 10s into one node, 20s into another node, and 30s into another node. That's a hash partition. Entire partition will put entire data into node 1 and node 2. When you apply round robin partition, it will distribute the data roundly. First record to first, second to second. If you have a third node, third record to third node, like that. Otherwise, it will start from first node again. Okay, that's why it's a round. Okay, round fashion. Okay, that is a round robin. Okay, so other than that, what else we had? If you go to input, you see all the partitions here. So you know what is the hash, you know what is unfair. Same partition is nothing but, for example, if pivot stage is using hash partition and you want to keep the same partition for sort stage also. So you can simply select same partition. So same partition will keep the partition as same. From here to here, data distribution on the backend will happen through nodes. So whatever it happens, see, data distribution on the nodes happens for each and every stage differently. Okay, because each and every stage is applying transformations, right? So after applying transformation also, you want to keep the you want to flow data in the same nodes. Okay, so here you applied hash partition and you want to keep same hash partition. So you can just simply select hash. Okay, same, sorry. Here you need to select same. But in the pivot stage, you could have selected a hash partition. That's what the meaning of same partition. DB2, it's a database related partition. If your source is DB2, then you select the DB2 partition. So automatically optimization will be done on the database, like we did for a sparse lookup. Okay. Basically, we are not doing anything. So database will be done. Okay. Inside database, optimization will be done. Okay. And what else we have? Modulus partition. Okay. So modulus partition is nothing but, how can I say? Number of records, record value divided by, let me check the, let me give you the example. So let's assume here I'm using so modulus partition will work for only integer numbers. If your key column is an integer number, then only it will work. Okay. So how would it work? So you have to apply modulus function, mod function. So mod is nothing but, so let's say I want to find given number is a even or odd. For example, let's say my data is like this. What happens? If my data is like this, 10, 11, 12, 13, 14, and 15. Okay. So here, how many nodes we are using? Here we are using 2 nodes. So 10 divided by 2. Remainder. How much is the remainder? It would be 2. So that means first record this goes to node 0. So node number generally starts from 0. Okay, let's assume it's a node 0 and it's a node 1. So first record goes to node 1. Okay. So here what is the, it's a modulus mod. Okay, so divided by 2, how much? Remainder will be 1. So it goes to node 1. So that will be 11 will be here. Similarly, like that. So 12 will come to here. All even and odd. It's not even and odd. For example, if your job is running on 4 nodes, 10 divided by 4, 11 divided by 4, whatever is the remainder, your data will be goes to that particular node. That's how the modulus partition will distribute the data on the backend. So do you understand what is round robin and what is modulus? It is important. This is also one of the interview question. So what are the types of partitions? Can you explain what do you know? So generally we use hash partition while we are doing a join. Entire partition also we use when we use a lookup. Round robin we apply sometimes. Okay, so it's a very rare. Modulus we never use it generally, but I mean unless you know you don't use it. Okay, it's a performance killer, right? So yeah, you have any doubts? You guys understand or not? With Prashanti.
Ankit, can you explain this modulus again?
Okay, so here how many nodes you are using?
2 nodes.
2 nodes. Okay, so this is the data in my input file. Okay, so divided by 2 mod function, right? What is mod function? Mod is nothing but you're just dividing. That's it. So here how many nodes I am using? 2 nodes. Value divided by 2. What is the remainder here?
0.
0. So it will go to node 0. What is the remainder here? 1. It
1.
will go to node 1. What is the remainder here?
0.
0. It will go to node 1. Node 0. What is the remainder here?
1.
Go to node 1. Similarly, if you have a 4 nodes, then you have to divide it by 4.
Okay.
Okay.
So the remainder
That's
is
why
0, 1.
yeah, remainder will be a 0, 1 always for any value if you divide with any value, right?
Okay.
Okay.
Okay, got it.
So if yeah,
Yeah.
if we have 4 nodes, if it is 0, 1, how it goes?
Okay, 4 nodes, sorry. 4 nodes means you will have a remainder chance of getting remainder 0, 1, 2, 3. So 10 divided by 4, how much is it?
Yeah,
Something
2.
okay, 2.5 something. So okay. 11
Yeah.
divided by 4, 2.75. Okay, something close to 2.75. Huh? Okay, let me
So
put the values
yeah.
here.
No.
11 divided by 12 divided by 4. Huh? 12
No,
divided by
no, 10 divided by 10 modulus 4, the remainder will be 2, right? So it will go to second node, right? 11 divided by 4, it should be 3. It should go to third one. Is it not like that?
No.
2 point something, isn't it?
No, remainder, right? It's the remainder, right?
Reminder. So
3.
4 to the right, it will be 3. Huh?
Yeah,
Sorry.
3.
4, 2, it
2.
will be 2.
2.
Right. So it says 0, 4, 3 there.
Yeah.
And then it will be 1. Yeah, sorry.
1.
Yeah.
Yeah.
So yeah, that's how data will be distributed. Node 3 and node 4. Got it? So Which record will come to node 0? 12. Node 1 will have a 13. Node 3 will have a 11. Node 4 will have a 3. Sorry. Node 1 is nothing but 13. Node 2 is 10. Numbers are wrong here. Okay. Node 2 is 10.
By
Node
one.
3 is 11. Yeah, that's it, right? Now it's matching, right? That's it. That's how data will be distributed. But here your key column should be an integer value. It doesn't work. If you take a key column with varchar, it will not work, right? If your input, if whatever, it's a key-based partition. So when you are taking modulus, you must select the key. What is the key to choose? Like for hash partition, you did choose a key. Similarly, here also you need to choose a key, right? If you have a generally we have a 2 node, 4 node, or 8 node. Okay, so if it is 8 nodes, you have to divide it by 8. So there will be 8 reminders. So your data will be distributed like that to 8 nodes. Okay, this is how the modulus partition will work. So what else we have? Random partition, you don't know really. So randomly data will be distributed randomly. Range partition, okay, so you can select the, let's see, what is the database? So while you are using aggregator also, what is the best partition while you are using aggregator? So based on your understanding.
Is it hash?
Yeah, hash is the best one. Why hash is the best one?
It's kind of a group by, so
Yeah, in aggregator we are doing a group by. Group by is nothing but hash partition does the group by, right? It will
yeah.
put all the groups into nodes. So it would be faster if you apply hash partition and sort the data. That is one of the performance technique. Okay. So range partition, let's talk about the range. The range is a key-based partition. So you need to select the key column. For example, if I give a employee number, okay. So employee number and you have a 2 nodes. Okay. So range, so some particular range. So data will be divided into 2 ranges. Okay. How can I give an example? Um, so here you have a 14 numbers. Okay. So in the range partition you have a 14 numbers and you have a 2 nodes. Okay. So let's say 2 nodes. So first 2 records will be in one, another 2 will be okay. So let's take 2 as a range. Okay. So if these numbers, okay, let's start from EMP. So this is one range. So it will be considered we have a 2 nodes. Okay. 2 records. So let's take this if these numbers are in a particular order only. Okay. This is a ascending order. So we have a this will be one range. So this set will be sent to one node, another range. So we have a 2 nodes. So it will try to distribute the records 2. Okay, maybe this is one range between this and this. These records will be sent to one node, another range to another node like that. So generally it would be there is a range partition right map range. So basically it will distribute equally. Okay, the number whatever you have given. Based on that number will be distributed. So if we have 4 nodes, these 4 records as one set. This is one kind of range. So that's how it would distribute. Okay, so these 4 into another node. If you have a 4 nodes, if you have 2 nodes, let's assume first records and another 2 records, set of 2 records. Okay, we have to perform the sort also here. Okay, that's how the range partition would work. Okay, so does it make any sense? So if you take, so what will happen if you take same data, you apply range partition, what would happen? So 10, 11 will be in one node, 12, 13 will be in another node. Let's take if we have only 2 nodes. 10, 11 will be in one node, 12, 13 will be in another node. Again, 14, 15 will start from node 1 again. Okay? Some specific range of records are moving to nodes. Okay, you good with that? What else we have? DB2 entire hash modulus random range round robin we talked about the key base random. Random is not a key base. So when you select a partition, if it is not asking key, then it's not a key based. Okay. So random I never used the random technique. So randomly it will distribute. But what is the difference between auto and random? So auto partition by default auto partitioning will happen. So but random, so what is the difference? Okay. So I need to check what is the difference between auto and random partition. Okay. So I will get back to you tomorrow on this. I forgot how the random works. Okay.
For the range, where did we give the range?
No, we did not give the range. We just select the key.
Uh-huh.
If you select a key, let's assume I selected this is my key column. So here how many nodes I'm having? 2 nodes. Let's assume. Okay.
Mm-hmm.
So two set of records. Data must be in sorted order. So 10 to 11, 2 records, it is a one range. Another set, it's another range like that.
Oh, okay, okay.
Okay, there may be a chance of repeating records also, right? 10, 10. So you have a 3 10s and 1 11. So 3 10s and 1 11 is one range. Okay.
Okay.
Okay, this is how it went.
Yeah, okay.
Okay.
So this
So
also should have the key as integer then, right?
yeah,
Okay.
you can alphabetical also, you can sort it. I never tested it actually. So you can try with alphabetical.
Okay.
But you cannot see it on the back end, right? Yeah, there is a option in data transformer to check what are the records processed by nodes also. I will show you that technique, how to see. So basically random technique also kind of auto partition only. So generally you cannot tell we cannot tell which record is going to which. Okay. So let me take that. Okay, fine. Let's put this random on the side. So random, we do not guarantee any other. Okay, forget about random now. Okay, so but yeah, so it should be good, right? So entire, you don't need a key. Entire data, hash partition, you need a key. Modulus, you need a key. Random, you don't need a key. Random, you don't need a key. Yeah, random, you don't need a key. And then range, you need a key. Round robin, you don't need a key. Okay, data will be distributed first row to first node, second to second, like that. Same partition will keep same partition as previous stage. Okay, that is about key based and non-key based. Okay, but when when your target is a sequential file, what is happening here? So you'll see different sort techniques here. You see here it's a collect partitioning and collecting. But when you go to other job, partitioning and collecting. Okay, it's collecting only. So here the technique is different. If your sequential file is, if you are using sequential file as a target stage, so what is happening? So sequential file runs on single node, right? Name itself, it's a sequential. So sequential file generally runs on single node. Okay, but Oracle connector is running on two nodes. So what is happening? So water is coming from two pipes and it is merging into one pipe here. So when data is coming, when, like, let's say, so you have a balls in two pipes, okay, and the end of the day it is collecting into one pipe. So you don't know what is the order of balls will be staying, but you have a order in each and every node, each and every pipe, two pipes separately you are keeping separate order. But when it is collecting into one node, you don't know the order, right? When it is merged into one pipe from two pipes, you don't know. There won't be any particular order unless you select it. So that's why you see here, you see different partition techniques: ordered, round robin, and sort merge. Ordered, so that means order the data. Okay, order the data while you are collecting from two pipes. So here data is coming from two nodes. So merging into one node. Sequential file runs on single node. So while you are merging, just order the data. Okay. So if the records are from the first record, keep it in first node. From the second node, keep it in second node. Okay, particular order. If you want to sort, then you can sort it based on the key column. Okay. If you don't want to sort, then if you want to maintain general order, you can use that ordered partition. So round robin, it will collect the first record from first node, second record from second node, third record from first node again. It will collect roundly. Okay. Sort merge. So sort merge, you will have to give a key column, obviously. So sort merge, it will merge the data from both the nodes and then it will sort the data. Basically, it will the pipe will wait for the both pipes to receive the water and then it will sort the data into that. These are the partitioning techniques, complete total partitioning techniques we have. Good. You understand why there are different partition techniques showing here?
Yeah, can you repeat ordered? Can you just repeat that?
So order partition, you don't need any key. It will keep all the records from node 1 first and then node 2 next. So if your node is like this, so let's assume your node is having like this 12, 3, 12, 13. So let's assume 14 and you have a data like this, okay? And you want to keep same data in the same order. Okay, so while you are collecting, there will be one node. Sequential file will be executing in one node. Now we are collecting the technique, collecting the partition. Collect partitioning we are using, okay? Because sequential file runs on single node, but the previous stage was running on two nodes, okay? So here we are asking, keep it in order. So this is one, all the records, okay? And then this is all, this is how it will keep, okay?
Yeah, got it.
Round robin is nothing but First record from first node, and then first record from second node, second record from first node, and then second record from second node. Like one by one, roundly it will collect. Okay. So sort merge, third one will be a sort merge. Sort merge, obviously it will merge the data. Okay, it will merge if you don't select, if you merge the data, and then it will sort the data based on the key column you select. So it will be in a particular order.
Yeah, so in
Okay.
what context do they use this different partitioning techniques? Like,
Okay, so yeah, so you are creating a file from Oracle connector. So while I'm creating a output file, I want my data in a particular sorted order. What will you do? Instead of using a sort stage here, you can use sequential file, partitioning, and sort merge to sort the data based on a department number or employee number, right? So even if you use a sort stage here, sort stage runs on 2 nodes, but sequential file runs on single node only. So it will not keep there is no guarantee that will keep the order. So you have to use this technique only. Understand now?
yeah,
Sort stage runs on 2 nodes, but sequential file runs on single node only. Then you cannot keep any order, guaranteed order, right? Then you will have to use obviously this technique. Okay. So these are the partition techniques. So make sure you at least read the theory part. Okay. I shared the documents. Did I share any PDFs with you?
no,
No, no. I will share PDF documents to go about the theory of this. Okay. So that's about partition techniques. So what? Let's talk about the stages. What we have. Switch we did not do, right? Let's do the switch. Okay, switch is a stage. Okay, so here everything is done. Okay, okay, so here in the switch stage, it is asking for select the column. Okay, okay, department number. What is the case condition you want to do? So here it says selector value equal to output link number. So how many output links I have? 2 output links. Link number, link label 0, link label is 1. So I want to select department number equal to 10. So you don't need to write the EPT equal to 10, EPT number equal to 10 here. It is already, the EPT number is already there. You just give a value, okay, equal, okay, you just give a value equal to link number 0. Similarly, you select another case because I have selected 2 links. So department number 20 equal to 1. So department number equal to 10 will go to link number 0. Department number 20 equal to 1. Department number equal to 20 will go to link number 1. That's what the meaning of this. Okay. If not found equal, if it is not found, if not found any of these value, what do you want me to do? You want to fail a job? No, I don't want to fail a job. I want to simply drop unmatched records because 30 is 30 there is an unmatched, right? So if you keep fail, job will fail. So generally we select a drop. If there is unmatched, in any row. If 10 is not found in any of the row, what you want to do? Just drop it, drop that row. Okay, that's what you need to select. If you select a reject, if you select output, you need to give a reject link. Maybe you can try that also. If you don't select if you select a drop, automatically data will be dropped. So, but what is the limitation here? Here you can only apply filtering on particular column only. It will not allow you to apply the filter on particular column. But when you go to filter stage, so you can apply this in filter stage. Select star from EMP where DEPT number equal to 10 and R, for example, let's take R DEPT number equal to 20. You can apply AND conditions, R conditions in filter stage. Okay, so here it will not allow you to apply any of those AND and R conditions. So you can directly copy and paste this logic in filter stage. Okay, so here DEPT number equal to 10 and EMP number equal to 87839. Okay, so no row selected. If there is a match, it will bring the row. So you can apply these kind of techniques in filter stage. So there is no limitation in a filter stage. But when it comes to switch stage, it will allow only equal values. Department number equal to 10 and department number equal to 20. So that's it. So take the single column and apply multiple filters. Okay, take the single column and then apply multiple filters. That's what the switch stage is used for. So you can apply n number of filterings, not only one. Okay, so you can apply a number of filterings on one column only. Okay, that's what you need to remember. So selector is a column name. Okay, so let's try to run our job and see it is working or not. So browse for a file w1.ds, which 1.ds, and then switch 2.ts. This is a switch reject. So generally, sometimes they may ask you what is the difference between filter and switch. So filter allows you to apply the filtering on top of with multiple columns, but switch stage will not allow you to apply the filtering on multiple columns. There is only one column selector. Okay, you see 3 rows to department number 10, 5 rows to department 20, and then unmatched is a department number 30, which is having 6 rows. So now do you understand what is the difference between filter and switch?
Yeah, can you explain
Yeah.
switch once again?
Yeah, sure. So if you go to switch stage, so it is asking only one column. Okay, so let's understand this first. Okay, so select star from EMP. If you understand this, then you'll understand data stage job easily. So department number equal to 10. Clear screen. Okay, select star from EMP. So select star from EMP where the EPT number, department number equal to 20 and EMP number equal to 7369. So there will only, how many records we will get? We will get only one record, right? Because I am applying AND condition. So if I want to apply same thing in data stage, which stage you will select? Which stage you will select if you want to do this?
You can use filter.
Filter only, okay? So there is no choice. So for whatever we have learned, you have to apply filter stage only. So in filter, there is no limitation. You can put where department number less than 10, greater than 10. And so, for example, I can apply like this also. If department number less than 20 and EMP number equal to 7839. Okay, do something like this also. So, but you cannot do these kind of things in switch stage. Switch will give you option to do filtering only on one column. That's it. So you cannot apply filtering on multiple columns. So all it allows is where the EPT. If you select the EPT, that's it. Only the EPT number. Okay. So you see here,
Yeah.
it is asking only department number. Other than you cannot apply the filtering other than department number here, because it is a select operation is there for particular column only. So department number equal to 10, but you can apply multiple filterings on one column only. Okay, case equal to 10 equal to 0 means all the 10s will go to link number 0. Case equal to 20 means all the 20s will go to node number 1. Similarly, you can have a multiple cases. If you give multiple cases, you have to give multiple links. Case number should be equal to the links you are using. Is it clear now?
So we can't use greater than or lesser than or any other things while using switch stage.
No, if you do that, then it will directly throw the error. Job contains one or more unattached links. All links must be attached before. Okay, for example, let's try this. File name empty. Let me give file name also. Then it will throw what is there. Okay, now here I did not give a I did not apply any condition here. Okay. No, it compiled, but it will fail. Okay. This should fail. If it is taking time, then it will fail definitely. So now switch stage is thinking, okay, where did this third link come from and why I don't have a condition? It's in dilemma now.
So if we give the condition, we can give an output links for that one to switch.
If you give a links, then it will work, right? So 1 second. So what happened? Why it is showing zeros?
So it will come in case 3 we can give like
If you give case 3, definitely it should work.
okay.
So case, for example, I will put 30 equal to second link. 30 equal to 2. Then let's run it. See, job has failed now. You see, because it cannot identify third condition for the third link. If you go to job log, okay, so here if you go to switch, output dataset 2 has no case value assigned to it. So this is a second dataset, it has a no value assigned to this. The job has failed. So yeah, if you apply a condition, now I applied another condition, then it will work. So if you are not applying a condition, why you have to give a output file name? Doesn't make any sense, right? If you want to capture any particular data, filter data, then only you give a file. Otherwise, why would you give output file? If you apply
So
two case
saying
conditions, you give only two
you're
output
saying
files.
that
Sorry, what is that?
I'm sorry. I'm just saying you just gave that department number in the input when you said that instead of giving department number is equal to 10, in that place you are giving it as a case number. Case is equal to 10, which is you are assigning the node value to it or the link to it.
Link
That
or
is
link,
what you are
not the
doing.
node. Link or
Sorry, a link
yeah.
name to it. So I'm saying
Link
instead
name
of
means
space is equal to
yeah.
10, you cannot we cannot give is space greater than 10 or less than 10 or any other
No, I
condition.
don't think. Yeah, so I don't think it will work. Okay, so here you are saying, let me try. You are saying up. Why can't we apply greater
Space
than
greater
10
than
or
10 or less than 10 or anything like that.
okay, let's try. Never tried it. I had this doubt and thought of trying, but I didn't try it. I think it will not work. I tried it, but I don't remember. Let's see. It works or not.
Because in SQL, you are giving the condition for DEPT number or any other thing, any other
Right,
column
yeah,
greater than or less than a certain
right,
number.
yeah.
So I'm just asking, will it work or not? Or do we have to
Yeah,
use
yeah.
the filter state?
That's a good question. Actually, I don't think it will work. I tried this before. So filter works for only equal value, not less than or greater than. Only equal values it will work. That's what I remember. Let's see. Yeah, it has failed. See here it is saying invalid representation of key field greater than 30.
Yeah.
Okay, only equal values it will work.
So in switch only equal values work.
Switch works only for equal value, but you can apply multiple equal conditions on top of a particular column. One, whatever is the column you have selected.
Okay.
That's it. Okay.
Okay.
So it's you have to choose. So when to use switch and when to use a filter. So obviously switch have a better performance than filter when you are using only one column. If you are using two columns in your filter condition, you have to go for filter only. No choice, right?
Yes.
So yeah, you should be able to explain differences between filter and switch. Right? What stages we have? Surrogate key generator, transformer, and slowly changing dimension. I think we can start with transformer tomorrow. So tomorrow what day? Saturday, na? So Saturday means Friday for you, right? Yeah. And we can start with the transformer tomorrow. Surrogate key and slowly changing dimensions after this. After transformer we can do it because whatever is the functions we use in transformer same we use in slowly changing dimension stage. So put these things two on a side. A sequence transformer may take 2 to 3 classes. Okay, I'll try to explain all the functions we use regularly. Yeah, so it has all the functionalities, all the string functions, how to apply, how to convert string from one form to another form. All these string related functions you can do in transformer. Okay. So let's see, let's check the layout, how it looks like. Transformer has a separate compiler. Okay. So it's a heavily coded stage in the data stage. So transformer is having C++ compiler on the back end. So most of the code is written in the C++ language. Okay. So if you open transformer stage, it looks like the lookup stage you have seen, right? So on the left side, it takes only one input. Transformer takes one input, but it will give multiple outputs. You can give a number of output links. Okay, there is no limitation. So here if you see, there are 4 steps generally transformer executes. Let's take only one column, don't get confused. So here what happens, first is a stage variable. In transformer generally, first the order of execution will be top to bottom in transformer. So first stage variables will execute and then loop variables. So loop variable is used to run a loops like a while loop, for loops. Okay. So stage variable is a temporary storage variable. So stage variable, loop condition, and then next will be a constraint. So you see here constraint and then derivation. So this is how the transformer will execute top to bottom. Stage variable, loop variable, constraints and derivations. Okay. So what is a stage variable? Stage variable is used to store the value, apply the transformation and store it for temporary purpose and use it wherever you want. Okay, for example, I'm applying my input data is this. Okay, so my input data is this. I want to add one value to every row. So it will be 11, 11, 11, 12, so something like this. 13, 14, 15 and 16, right? Because I added 1 plus 1 to each and every row. So I will store this value somewhere and then I will use it wherever I need it. I will use it multiple times. Store the value and use it in multiple places wherever you need. So if I want to store this data after applying transformation, so this is the place you use. Stage variable is used to store the values and then call it wherever you want. So I want to run a loop. So I want to run a while loop, then you go for loop condition. Okay. So this is how I have examples for each and every stage. Okay. After that, we are going to talk about constraint. Constraint is nothing but a filtering in data stage. Okay. So filter stage, generally we apply filter stage, right? Same filtering you can do in transformer stage also. So here you don't need to write anything manually. All is if you right click and go to input column, department number, again you right click. So you see equal, not equal to, less than, greater than, less than. Everything is here. Say equal to, right click, string. I'm just showing the layout. Okay, don't worry, I'll be teaching all these. Okay, just showing how it will look like. 30. So here I did not write anything, only values I typed this. So after that you want to apply AND condition, right click and right click input column, employee number equal to, right click, string 7789. So everything is there for your need. Okay, all you need to know is how to use those functions. That's it. So this is a filter. So if I apply and run this, so select all the output columns to output link. So job will execute. If there is a match, that row will be sent to output. Other if there is no match, nothing will be go to output. Okay. So this is how the transformer stage layout. Okay, looks like. So how it will execute. Okay, but it's a performance killer obviously because it is having bunch of code on the back end. Okay, so it's a heavy stage, right? So this is the stage we regularly use to apply all the functions. Okay, so you can create the column. Let's say I want to create a dummy column. So you can simply create a column, and I want to pass some value, some constant value. Okay, you can pass it. Okay, so you can rename the column name here. EMP number on the left side in the inputs. I want to change it to EMP underscore number. So I can simply change it. So transformer allows you to add column, remove column. So I don't want these two columns to my output. Delete the column. It is there in input, but it's not in out. You have not selected in output. You can add columns, you can remove columns, you can rename the columns. You can filter the data. You can apply string transformations. Okay, you can apply loops. Lot of functionalities are available in one place. Okay. So tomorrow we can start doing